Hi, everyone. This is Morgan here with Positive Approach to Math. We are starting our first Algebra 1 lesson from our algebraic expressions topic. So just a little bit of a background or a recap. All of our videos will begin with a little bit of a for your information where we break down any important information for the lesson. We then will go into some examples. Wrapping up the examples, we'll summarize what we just talked about, and we will go through any helpful hints or important reminders. And then I will leave you with 6 U-tries. Following those U-tries, you can either click on a link to go right to the answer key if you want to try them on your own and check your work, or you can click on a link to another video, which will break down those U-tries. I totally recommend giving them a shot on your own, but if you're a little bit stuck, no problem. I will break those down for you. So I hope you find this helpful, and I look forward to working with you in Algebra 1. So in order to start, we need to know the important vocabulary that's going to guide us through all of Algebra 1, Algebra 2, and beyond. So we're going to start with parts of an algebraic expression and just being able to identify the vocabulary and find it in an algebraic expression. So the first thing we have in algebra is a variable. We're no longer just working with numbers. We will use letters to represent our unknown values or an unspecified number. So if I give you something like 3x here off to the side, that x is a variable. It can represent a specific number or an unknown value at this time. From there, we have an algebraic expression. So an algebraic expression is something that contains at least one variable. So if I take that 3x and then say I just add +4, right? That 3x plus 4 is an algebraic expression. There is one variable in the picture. It doesn't just have to be an x. I could have said 3x plus 4y or 3x plus 4x squared, right? But what's important is that you see at least one variable in the picture, and it's typically things are separated with a plus or a minus sign, okay? Our next vocabulary is terms. So terms can be single numbers. So 4 would represent a term. It can be a variable. So x is a term, or it can be the product or quotient of numbers and variables. So 3x is a term. I often say terms are everything separated with a plus or minus sign. So if I see a big chain of things being added or subtracted, each individual thing that comes before or after a plus or minus sign is a term. So it can just be a singular number, it can be just a singular variable, or it can be that product or quotient of a number and variable combined. Okay, so 3x is a term and 4 is a term. Okay, now what's important is that you can pick out and identify like terms. So like terms are terms that have the same variable, so they have a letter attached to them, and those variables have the same exponent. So if I were to put something like 3x plus 4 plus 2x, right? That 3x and that 2x are considered like terms. That's because they both have that variable of an x, and the exponent on each of those x's, when there's not one there, it's technically a 1. So they have the same variable and the same exponent attached to their variable. So those are like terms. If you just had a singular number, so say I add like a -5 here, right? The 4 and the -5 would be like terms. So our next vocab word here is a coefficient. A coefficient is very simple. It's the number in front of a variable. So anytime you see a variable, no matter what, if it's x, x squared, y, all attached in one thing, the coefficient is the number in front of it. So if I'm looking here, 3 is a coefficient and 2 is a coefficient because they are numbers and they are in front of a variable. Okay, 4 and 5 are not coefficients because they do not have a variable attached to them. Instead, they take us to our last vocab word here, which is a constant. A constant is a number that stands on its own and doesn't have a variable attached to it in any way. So 4 and 5 would simply, would simply be constants. And all constants are like terms. That's super important to be mindful of, that like terms don't just have to have variables attached to them. They can be singular numbers. I always say the singular numbers all come together to become one number, right? So that's our for your information. That's our vocabulary, and that's going to guide us not only through Algebra 1, but you're going to see that vocabulary come up in Algebra 2 and any math beyond that. So before we dive into doing some math, I think it's important to look at an example and to be able to identify the terms, the like terms, the coefficients, and the constants. So obviously we have variables here. We have something with an x, so therefore we have an x squared and we have an x. So we have an algebraic expression, and so therefore we can pull apart the terms, the like terms, and any coefficients or constants. So just a little recap, all of these are terms, right? So every single thing in isolation is a term. 5x squared is a term. 2x is a term. Remember, I said anything that's separated with a plus or minus. 3x squared is a term. Now I'm going to call that -6 because it's really like we have plus a -6. So -6 would be a term, okay? So all of those things separated are individual terms. Now, our like terms, we're looking for things with a common variable, so the same letter. So you see 5x squared, 2x, and 3x squared. They all have an x. But in order to be like terms, they must have the same exponent. So if I look a little bit deeper, 5x squared and 3x squared, they have the same variable and the same amount. If we're moving down the line here, our coefficients are any number that is in front of a variable. So 5 would be a coefficient, 2 would be a coefficient, and 3 would be a coefficient. And then last but not least, our constants are anything that don't have a variable attached. So 6 or -6 would be a constant, okay? So now what we're going to do is we're going to look at another example, and we're going to actually list them, right? So if I'm looking here, we are going to talk about noticing that, yeah, we have things with an x and a y attached to them. So just to be clear, it's not 3x squared and y. Those are not three terms. That quantity, 3x squared y, that is a term. So our terms are everything, every product, right? So all of those are terms. So we have 3x squared y. We have -2x y squared. We have 5x squared. We have -6x squared y. And we have 4x y squared. Oh, okay, that looks good enough. Our like terms are things that have the same variables and the same exponent on those variables. So notice all of them have an x in it, but in order to be a like term, they have to have x to the second and then y to the first, right? To be a like term with that guy. So I'm looking, I'm skimming, I'm saying, do I see something else with an x to the second and a y to the first? And I do see that here. So those would be like terms. So we have 3x squared y and -6x squared y. Those would be like terms. Do we have any other like terms? And we do. If I look here, I see an x to the first degree and a y to the second degree. I see that also down here. I see an x to the first degree and a y to the second degree. So those are like terms. So we have -2x xy to the second goes with 4xy to the second. So we have another set of like terms. All right. There is no like term that goes with that 5x squared, and we don't want to mistakenly say, oh, well, it's an x squared, so it will go with this group, right? That's not actually the case because that x squared, the 3x squared, has a y attached to it, where the 5x squared doesn't. So you would just need something with another x squared, and we don't. So that guy doesn't have any like terms. Our coefficients are everything in front of a variable. So our coefficients here would be 3, -2, 5, -6, and 4. If there's a variable and there's a number in front, that would be a coefficient. Now, one thing to pay attention to is, say you had a term plus a y squared, right? Be alert or be on the lookout. There is a coefficient in front of that y squared. It's that imaginary one, right? So there is always a coefficient in front of every variable. If there isn't an actual number there, it's the number 1. Okay, so we just want to be on the lookout for that. And then last but not least, our constants. Are there any numbers that stand alone with no variables? And the answer is no, right? Every single number you see has a variable multiplied next to it, a product, right? There is no standalone numbers, so therefore there are no constants. So I'm going to write NA, non-applicable. You could write the word none. And if there was one, you would just write what it was. Okay, like the example above, we would write -6 as our constant. So that is our first lesson. Some summary to wrap up everything we just did. Some summaries and or our summary and some helpful hints would be, remember, terms are separated with plus and minus signs. So if they're glued together, 3x squared y, that's glued together. There's no plus or minus sign separating it. That's not 3 individual terms. That's one big term, right? So you're looking for things separated with plus or minus signs. And then remember, like terms must not only have the same variables, and it can have more than one variable, but they must have the same exponent for each variable. So even if they both have an x and both have a y, the x's must have the same exponent and the y's must have the same exponent. So please be on the lookout for that when we're looking for like terms. Anytime you have a number in front of a variable, you have the coefficient, and don't forget that coefficient of 1. And it is okay if you have no constants. Just be mindful of that. That is perfectly okay. So I leave you with only 2 problems in this first lesson. You are going to try to identify the terms, the like terms, the coefficients, and the constants for each of the following. Now, just a reminder, if you need help, you can watch my video breaking down these 2 you try problems. And if you want to check your work, you can click on the link that's going to pop up in a little bit, and you can check your work for that.